Section 2.1, Visualizing Variation in Numerical Data. So in this section, we are going to start creating charts and graphs off of the data that we have. The distribution of a sample is a list that records both the values that were observed and the frequencies of these values. And just as a reminder, frequency is the count of how many times each value was observed. This is the first step we want to take in almost every statistical investigation. We want to visualize what the distribution looks like, because then you can start to see patterns that you may otherwise not be able to see. Here in our first example, we've got some data from the NCAA. This is the number of goals scored by first-year NCAA female soccer players in Division III in the 2012 season. So we do have a list of numbers. We know what they mean. They have context, so this is our data. However, with just this string of numbers given as is, it's really hard to see patterns. It's hard to answer questions like, what's the typical number of goals scored? Or is 19 goals an unusually high number? So the first thing we want to do is make a frequency table for this data. So in a frequency table, all we want to do is write down all of the different values that we see. So the values we see are 9, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, and 35. Those are all of my data values. And then we also want to record the frequency. How many times did that value show up? So the value 9 only showed up once, 11, 1, 2, 4 times, 12 once, 13 was 5, 3, 2, 4, 2, 2, 2, 1, and 1. So that is a frequency table. It's a lot easier now if we just look at it at a glance. It's very easy to tell that 13 was the kind of most typical number. It was the highest one. And we could answer, you can just kind of get a little bit of a better visual and answer some quick questions like that better than you could when it was just a string of numbers. Okay, so let's think of some actual graphs that we could use for visualizing numerical data. We've got two ones that we're going to talk about today, dot plots and histograms. So a dot plot is just when you use a dot, place it above the number line where the value occurs. They're very simple graphs. Histograms are a little bit more involved. This is when you divide your number line into what we call bins of equal length, and then you draw vertical bars where the height is proportional to the number of observations inside that bin. This is an important piece of information here. In our particular book, we use what's called the right-hand rule. So we put any boundary observations in the bin to the right. Changing the width of your bins can drastically change the shape of your histogram, possibly. If you make your bins too big, you might lose too many details. And if you make them too small, you might see too many details, and it might be a little bit overwhelming of a graph to look at. Relative frequency is just when you change your numbers to the proportion or to the percentage. So instead of using the actual frequency, the number of times, you turn it into a percentage. That's what relative frequency means. And then the last visual that we're going to look at today is called a stem plot or a stem and leaf plot. These are useful for visualizing numerical variables when you don't have access to technology and if your data set is small. So you do not want to use stem plots if you have thousands and thousands of data values. It would be not a good idea to use one of these. Your leaf in one of these is the last digit of your observation, and your stem is anything that precedes that. So for example, in the number 60, 6 would be your stem, 0 would be your leaf. And in the number 632, 63 would be your stem, and 2 would be the leaf. Now we're going to stop this video right here with these explanations, and we're going to finish the rest of this note sheet in a separate video where I will actually bring up StatCrunch, and we're going to use StatCrunch to create all of these different kinds of graphs. We are going to pull up StatCrunch and we're going to create a dot plot, frequency histograms, and another frequency histogram, stem plots, etc. So definitely keep your note sheet out